Everybody, Swarsky here. Let's go ahead and get into the second part of our check-in, which is the proofs section. Now remember, we have 3 questions for this. I have written, or I've set up the flow chart. Now again, you might not have done that. That's totally fine. I'm just making it a little more organized so that when you see this, it makes a little more sense. And it's easy for me to write because I'm doing this on a mouse. That makes it a little more difficult. So let's get into solving these pieces. Now you'll see this is out of 3 points. I'd say pretty much you needed these pieces, these pieces for a point, final one for a point. So kind of each chunk here is worth a half point, one half, one half, one half, one half, and then the final one is actually filling out some of this stuff so I can see. So if you had any highlights or anything like that, that was showing that you made some mistakes. So make sure also if you need to pause, rewind, ask questions, please do that at any point during this video. And also remember that you need to not only correct this, but you need to do your reflections, okay, on what you did wrong and what you should have done correctly, okay? Let's get into solving number 2. So we're given that E and G are congruent, which should right away say that, well, I know right here. So however I need to mark that, this one and this one. Now I'm going to use the same color because this one's pretty obvious. And F is the midpoint of EG. Well, that would mean that this and this are the same. So right now I have 2 pieces and I need the third, and that's going to be given by this chunk here. Let's mark it with 2. Okay, and I'm going to mark that angle 1 and angle 2 for when I write my proof out. Now I have 3 parts, which is actually angle, side, angle. So let's see what we can write here. So I should say, and I'm not going to put everything in here. So E and G are the same. How do we know that? Well, that's the one thing that is for sure given. The next thing that I know, EF is equal to FG, and you could have had FE and GF. You could have them flipped around. It doesn't matter. Just those 2 segments named in some way, and that's by definition of midpoint. Okay, now some of you on this step marked this, and I think that you were trying to assume because F was the midpoint, I could also name those as congruent, and you cannot do that. Same thing with these. I think some people thought these were parallel, and there's just, well, there actually is a way. Because I have these being congruent, I know those are parallel, but I think people put them as, or they're parallel, but people put the side lengths DE and GH is congruent, and that part is incorrect. Okay, and then the last thing, I know that we'll call it 1 and 2. 1 is equal to 2, angle 1 and angle 2 are equal, and I know that because of vertical angles theorem. Okay, now I have my 3 pieces, which flows into DEF being equal to HGF, and I have that because of angle, side, angle. Okay, I'm trying to think of anything else I noticed. Some people didn't write this piece in, and I did mark that off. You do need to show what you're trying to prove at the end. That should be your last step, however you mark it. Some of you had 2-column proofs, and those were totally fine. Just remember, if you have any highlights in number 2 here, that means that there was a mistake and you need to correct and reflect on those things, okay? So there is the first one. Next one here, a lot of things were happening with this. So first thing we're going to mark here is our given. So we know that MR, which is this piece, is congruent to NP. And not only that, we know that these are parallel. Parallel should be the giveaway for alternate interior angles, okay? And I have those alternate interiors right here. I'm going to shorten this up so you can see it better. So here's my parallel. So let's see if you can find it here, because I had a lot of people give me some different answers. There's my parallels. Here's my transversals. So which angles are inside of that transversal and parallels? Well, that would be angle 1 and angle 4. I got a lot of angle 2 and 3s, which are close, but not quite there. Okay, and then I also have this shared side right here, okay, which is MP. So now we can actually mark up our figure here. We know the first thing, or we can fill in our proof. We know that MR is equal to PN, and we know that because, hey, it's given to us. Okay, the next piece, I'm going to do the alternate interiors. So we know that angle 1 is equal to angle 4. Usually I'd be writing the symbols for it, but I'm a little hogtied here with doing class kick and for sake of time. And I know that because of alternate interior angles. Okay? And then the last one is a shared side. That would mean that MP and MP are the same. So that's what I'll say. So MP is equal to MP. I know that because those are shared. People might have also said same or reflexive. That's the same thing. All of those are okay. All that flows into what I'm trying to prove, which would be that MRP, triangle MRP and P and M are congruent. And how do I know that? Well, that in this case would be side angle side. Okay. There is that second one. Remember, at any point, if you need to pause, rewind, take some time, see it again, hear it again, any of that stuff, make sure you're doing that with this video and not just running through, just so you can make sure that you understand what you did wrong and make those corrections and reflections, my friends. Last one. This one has a little bit of a bigger step to it, which is why it's that level 3, and we called it 4 points. We have this last little piece in there. So let's see what we can do with our figure here. So we know that QR, which is this part, I'm going to actually highlight these different. QR and, I'll use red, and RS are the same. In this case, SR. These two are the same. I know that RUT is an isosceles. So I'll use green for that. So I know this as well. This here, RUT, is an isosceles triangle with vertex R. That just means that R is the top of our isosceles. So that tells us that we got some base angles here and here. And we also know we have some congruent sides based off isosceles. Okay? I'm trying to prove Q and S are congruent. Okay, that means I'm going to have to show some triangles have some congruencies. Now I can do this two ways. The first one that I'll show you is that if I'm using this triangle here, I have a side vertical angle and then this side because of isosceles. Okay, so that would mean, so let me fill this out so you can see. So regardless, we know that QR is equal to SR. Okay, and that's given to us. The next thing we would know, let's call this, let's just mark this 1 and 2 just for ease of identifying. We'll call this, let's say angle 1 is equal to angle 2. We know that because of vertical angles. Vertical angles theorem. And then finally, I know that my sides, UR, you can see that at the top of the screen there, that UR is equal to RT. Well, that's because those are isosceles. So that's by how we define our isosceles triangles. Okay, that flows into these specific triangles, which would be, in this case, QRU, and you could have named it different. And then that would mean that triangle would have to be SRT, and that would be because of side angle side. And finally, that would tell us that angle Q and angle S are equal because of, this one would be CPCTC, corresponding parts of congruent triangles are congruent. Now, here's the difference. This is one way to do it, okay, using those. Now, there is another one. And let me show you that. Let me get rid of some of this stuff because I don't need to use, oh shoot, I don't need to use that. I'm still going to use the fact that I know this is isosceles, which gives us these angles here and those congruent sides, but I'm going to use this here, 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 which you see still uses Q, which is what we need for sure. And then I'm going to do it to this one, and this one, which now gives us this whole side, this whole, and that side's congruent, this because of isosceles, and then I have a shared side here. Okay, so I again have side angle side, okay, but a different side angle side, okay? So that would change. I'd have to change a few things, so let's do that. Let's call this, so I'd have to change this one for this. We'll call this just angle U, just to make it easy, and angle T. Some of you numbered it, some of you used angle SUT and QTU. You named them differently, it's great. I'm just gonna generalize for our ease of understanding, and that would mean that's because of our definition of isosceles. And then finally, we need to say these big ones from S to U, from here to there, are the same. So SU is equal to, which one? QT. So that whole side. Now, why? Some people had a couple different answers. The one that seemed to, I can see what you'd actually need a step before, but I got enough from it, would be segment addition. Like if you'd have to do a segment addition policy, but I get what you're saying when you do that. And then I think that'd be the best one. I don't think I had anything else from that. So SU and QT, but everything else is the same besides. You still got to do, oh, no, sorry, this changes. Now I'm not using QRU, I'm using QTU and SUT, okay? So the big triangles are still by side angle side, still ending with Q and S equal to each other by CPCTC. So you see there's two different ways to do it. So look at the way that you did. You can go back because I showed both ways here. So that is it. Again, if you had anything highlighted, that means you have something to correct and you have something to reflect on. Make sure you make a little paragraph with that. And I have retakes for you to make sure that we understand what's going on. So good luck to you. If you have any questions, let me know, and we will see you later.